What's going on, man? We in the building. You know what time it is. It's the space show. We about to get it popping. Miss Lisa, I see you in the building. We in here with my dog, Anthony Bowman. You know what I mean? Welcome. What's
Yo,
going on with your dog?
peace, man. Just ready to get it in. Get to talking about a little bit of this cosmos in. It's
Yes,
always good to
indeed.
be able to talk about the cosmos.
Yeah, man, a little something to get our mind off this war that's going on right now, man. That ain't a war, but is a war.
Yeah, something like that.
You
Something
know
like
what I
that.
mean? Positive thoughts out there to the ones that's affected. You know what I mean? I got a partner that's working out there, man, on a government contract, man. He tell me they been intercepting missiles all day, man. So, I just hope everybody be safe on the America end. You know what I'm saying? But yeah, man, let's get on that space talk, man.
Yeah, yeah. I wanna send a shout out to the troops, man, that's over there putting it on the line. No matter what the reason is, they doing what they got to do. So
Already. We don't even see it. Look, we got peace of mind because there's somebody out there doing the dirty work. You feel me?
indeed, indeed. So nah, it is what it is, fam. I'm
Man,
just
I remember I
I'm
used
just
to
glad to be on this side of it.
exactly. Look, I used to talk crazy about it. Yeah, man, the white man. Woo. Shit. Well, we
Uh,
need that military out there, yo.
you gotta have
We
it,
need
dog.
them. We need them, boy. Like it or love it. You know what I'm saying? Or hate it. Hate it or love it, man. We need them boys, man. So, they just following orders. You know what I mean? At the end of the day.
That's what it is. They got a job to do. They signed up for it, so
Yeah,
it
man.
is what it is. But yeah, man, it's always good to be able to concentrate on something else, or at least think about something else. And the cosmos is a great place to be. you
Yeah,
know,
man. Go outside and look up at the stars tonight. You know what I mean? We want, take you on a journey.
yeah, yeah. We're gonna get it in. Talk about just try to get a good idea of where we fit into the Milky Way, and then further out.
Sure do.
We touched on the cosmic web last week. That's the big picture. That's the grand picture.
Mm-hmm.
And we're gonna tighten it up a little bit, and we're gonna start out, in our galaxy. And then, like I said, as far as the astronomy club goes, we got several pictures of objects within the Milky Way. So we're gonna try to, get an idea of where those objects are located based off of how we can view them from the Earth. So
Facts.
yeah, but
So,
yeah, man, it's good to be able to get into the cosmos.
yeah, man. I got that cosmic perspective thing going, so I'm all with it. You know what I mean? I know how insignificant but special we really are. You know what I'm
Yeah,
saying? We connected to the cosmos. We are the cosmos. You know what I mean? It's the big picture at the end of the day. You know what I mean? Like when you tie in all of the things that the pseudo killers talk about, it all connects. You know what I'm saying? If we talking about the brain to evolution to the cosmos to history, you know what I'm saying? All of it connects together to get like all of the pieces of the puzzle. You know
yeah,
what I'm saying? When you're talking about existence and reality. So that's what I like about it. You know what I'm saying? The cosmos just gives you the big picture, the
yeah.
universe. You know what I'm saying?
That's the big picture. Yeah, exactly.
It makes you look like, man, you think your problems is something, man. When you zoom out, it's like, yo, we a speck of dust.
Bro.
Like I'm thinking about, I got a funeral to go to in about 2 weeks, 2 or 3 weeks, but then I'm thinking about the lifespan of a human, and I'm like, yo, this is like a blink of an eye.
Yep.
When you think about that speck of dust, and you think about the animals on the planet, and you think about, just how short life is, you know what I mean? It's man,
Yeah, dude.
bigger than us, yo.
But but this little 70, 80 years we spend on this earth, dog, don't compare
At
to
all.
living in the cosmos. You
At
know,
all.
yeah. So just being able to study it and get an understanding of it in that short amount of time that we're here, dog, that's a phenomenal feat. You know,
Big
excuse,
facts.
you know what I'm saying? That's bruh.
Man, just being able to exist is a treat though, like you like you said.
Yeah,
Yeah, it's a it's an experience that a lot of humans didn't get to have. So, and a lot of humans had and is gone. So, hey, man, enjoy life while you here, yo.
yeah,
And,
man.
and try to learn everything you can, man.
Yeah. Uh, I worry about what happened after death. After death,
Right.
you know what I'm saying. But right now, dog, I'm trying to get an understanding of what's going on
Right now. Exactly.
right now. So
Yeah.
yeah, dog, we got the we touched on the light speed and how all that stuff worked. That's amazing to me.
Man.
You know.
Who knew light traveled? You know what I'm saying? Like you hear it
Yeah.
all the time, but when you actually understand the photon hitting up against the wall, bouncing off the wall, hitting and your eye only getting that information if that photon hit it. You know what I'm
Mhm.
saying? Like just understanding that, mind blowing.
It is, dog. And at the speed that it happens at, you know, when we look up in the sky and we look at the sun, I mean, we see the sun, but we don't really know and understand that the light that we see has been traveling for 8 minutes. So we're
Hmm.
looking at the sun 8 minutes in the past,
Yeah.
you know. So what that means is if the sun was to just blow up or disappear, that's not going to happen. But if that was to happen, to put it in perspective, we wouldn't see it until 8 minutes later.
Right.
You know what I'm saying? So for them first 8 minutes, the sun would still just be shining regular. You know what
Hmm.
I'm saying? And then after 8 minutes, all of a sudden you'll see that light from that event will finally make it to us, dog.
Yeah.
But it's only 8 minutes, but still, it's not instant. So, you
How
know,
about how about this? And if the nearest star with what is it, Centauri, right?
yeah, Alpha
If
Centauri.
if that blew up, we that's 4 light years away. We wouldn't see that until 4 years later.
Yep. It'd be
You know what I'm
4 years
saying?
old by
It'd
the
be
time
4 years from now.
that
Matter of fact, the stars that you're looking at right now, you're seeing them millions of years late.
yeah, exactly.
They ain't even there no more. You know what I'm saying? The photon just traveled all of them trillions of miles to get to your eye socket. You know what I'm saying? And it's giving you information that was there millions of years ago. That's crazy.
Yeah.
The physics is crazy. This universe is weird. We got Gary in the building, man. What's happening with your dog?
What's going on, everyone?
Peace. What's happening, Gary? You doing all right?
That's good.
Yes, indeed. Yes, indeed.
Yeah.
We got my bad. Lamar Pope in the building, 306. King Hercules just came in. Welcome to the show, dog. Got Omar Reed, man. What's going on with you, man? Long time supporter. You know what I mean? Shoot, if you want to go on and get it in, Ant, you know what I'm saying? We ready. You know what I'm saying? Hey, we gonna leave the panel open later on. You want to jump on, chat with us or whatever. You know what I'm saying?
Yeah, that's what's up. Yeah, we can get it in. You can go ahead and share my screen.
All right. And make sure y'all share the show, man, and like it. Subscribe if you ain't already subscribed. You know what I mean? We got more to come.
All right. Is it sharing, Kent? Can you see them?
Yeah. Yeah, you got look like you it look like you sharing the wrong screen though. You sharing the StreamYard. So you might have to go to Galactic something.
Yeah, I'm in the stream yard.
Yeah, so you got to go to your the screen. I think you got to pick the window for whatever your slide is at.
Okay, let me see how I get that on here.
What you been up to, Gary, man? I see you in there, man.
Just chilling, man, on a Saturday, man. It's nice here. We had all them cold temperatures. It was like 75 degrees today here. So I was out enjoying the weather, man.
Man, it feel good over here too, yo. It was raining yesterday, man, but shoot, today, man, a nice little breeze going.
Trying to, I don't know how I get this in there. Can you pull this up then?
Send it to me. You talking about that's the slide you had?
Yeah,
All right, let me see. Hold on a minute. Let
I
me
can
see.
send it to you real quick though.
I think I got it. Man. But shoot, go ahead and I'll go ahead and talk to the people, man, while I pull this up real quick, man. So we gonna let's see.
Yeah, I can start talking though. But yeah, what we gonna forgive me, y'all, but yeah, what we're gonna get into is basically what's called galactic cartography or cosmic. Yeah, galactic. We're gonna start with the galaxy. So basically, what we're talking about is the structure of the Milky Way. And like I've said before, those we get the structure based off of the movement of the stars. So being able to measure all the stars is, how we get this information. And the instrument that's used for that, like I've mentioned, it's called the Gaia Observatory, which it's offline now, but it was a project that was going on for about 11 years. I think last week I said like 20, but it's more like 11 years they had that going on. And what they were doing is, like I say, just getting as much information as they can about the stars of our galaxy. So we're basically trying to piece it together from the inside of the galaxy, because we'll never be able to go outside of the galaxy and look at, we can put a ship on its way right now, but it'll be a long time before, many generations before we could ever get that. So it won't happen in our lifetime. But the galaxy consists of a supermassive black hole, which is in the center. Most galaxies do contain a supermassive black hole. Ours is about 4.3 million times the mass of our sun. So that's basically like having 4.3 million suns. You know what I'm saying? But being able to take that information and build a model of what we do, or where we are, not what we do, but where we are in this Milky Way, is pretty spectacular. So let's do this. If you can't go to slide number 4, where it talks about the structure of the spiral arms and the way they're made. Yeah. Okay, we are what's called a spiral galaxy. We got 2 main arms, which are the Perseus arm and the Scutum Centaurus arm. And then there's a few, minor arms, and you'll see on the next one here, what that looks like. So our comprehensive, you'll get a comprehensive shot of what the Milky Way basically looks like. But like I said, it's two major arms, and then there's a bar in the middle. You can go to the next one. Okay, here's basically the structure of the Milky Way. Now, like I said, this type of view here, you won't, there's no way we'll be able to actually get a picture of the Milky Way like that. So that's basically a comprehensive view. But if you can look in the center, you see that's where the black hole resides, right there in the center of the galaxy. So being that right in there, like I said, in the central region there, that's where the black hole resides. Now you have two arms that are spiraling off of that on each end of that bar. And if you start here, like on the bottom part of that bar, you'll see that's the scutum arm. And if y'all need to, you can expand it to see the writing. But we have the scutum arm, scutum centaurus arm, which is one of the major ones. And then you also have the Perseus arm. Now, the sun, our sun sits right along in there where you see that Perseus arm. It sits right along in there. That's our estimates anyway. So our solar system is about halfway to the edge from the center. So what you'll see is in most writings or most papers, they'll say that we are about 25,000 light years from the center of the Milky Way, being that the Milky Way is like 100,000 light years in diameter, which would, so that'll put us, like I say, right along here in that Perseus. It was really called the Perseus, not Perseus, the Orion Spur. And, just understanding where all this fits in. I mean, like, we talk about, I think it was Sosa mentioned, to be able to get into this type of study, you got to be eating good. You know what I'm saying? I mean, things have been pretty good where you could settle, you know what I'm saying, and try to get an understanding of really what's going on out there. And that's where we are now. We thank the ancients for their contributions and the foundation, you know what I'm saying, of where we are now. They were that. They laid the groundwork. They started to try to figure out answers to the questions that they had. And they were able to, use different objects and techniques to help better their understanding for their survival. So big up to them. But this, like I said, this something real quick. We don't want to drag it out too far, too long. We just, like I said, just get a good understanding of where we are. And then we're going to start adding, looking at where the objects that we take pictures of are located in these arms, and what's going on with those objects. But this is the main thing right here. I want to, start off slow. I don't want to go too fast, but just know that we have two main arms, and in those arms, that's where you really find the concentration of gases, stars, just most of all the objects. We spoke about, I showed y'all a picture of what we call Bobby's Nebula, the Orion Nebula, and that's one of the major star forming one of the major star forming regions that's closest to us. It's not too far from us. So we're, like I said, we're in the Orion Spur. It's about 1,400 light years from us. So it's gonna be in that same vicinity, in that Orion Spur. So that's pretty close to us. It's very, very bright. You can see it with the naked eye. That's one of the main objects that dominates the night sky. It's in Orion, right below the 3 stars that form the belt. And like I said, for our catalog, that'll be Bobby's Nebula. So that's what we call it. But that's where we're gonna start at. And I just, I appreciate y'all for coming through. Don't let me hog it, man. Y'all, if you got anything y'all want to add, shit, jump in. It's all good.
No, it was Miss Lisa was asking if at the center was there a black hole, and I was letting her know, yeah, it's the what do they call that black hole at the center of our galaxy?
Yeah, that's Sagittarius A star.
Right.
And when you get into the actual that center bar there, that's where most of the action is happening at. So that's why it's the brightest. That's going to be the brightest area of any galaxy. It's right there in the center, and that's where you got most of the stars, a lot of globular clusters. It's a lot going on in the center of our galaxy, and that's most galaxies.
Yeah, the supermassive black hole. That's the word I was looking for.
Yeah, it's a lot going on there. So that's where you get a lot of information about galaxy, the contents of what's going on, how all the stars. You can get the direction of motion of a lot of those stars, and that's really right there in the center. But yes, Miss Lisa, that is correct. It'll be that one that in the center of that bright spot there. And that's mainly what you see when I speak about looking at Andromeda, which is 2.5 million, estimated to be 2.5 million light years away from us.
Mm-hmm. Another galaxy.
Yeah, it's the closest major galaxy to us. And when you look at it and you see it with the naked eye, which you can, in a dark spot though, you can't really see it with all the light pollution. But yeah, that's what you're going to see. You're going to see the center of the galaxy. You're not going to be able to see the structure of the galaxy. You won't be able to see, all the whole galaxy because it's too far away. But that center is enough going on in the center of it to where you can actually see that part. And it'll look fuzzy to you. Like, I know y'all have heard me say that several times. It'll look fuzzy. It won't look like a star. You'll know it's not a star. You'll immediately know that part. So, just know and understand that's what you're seeing. And depending on if the black hole is actually active, you might even see a little more. But if there's a supernova going off in that galaxy, you'll probably be able to see it.
And to clear up a misconception that I had a while back, man, I was thinking that there was only this, like a black hole right here, but there's black holes all throughout the galaxy.
Yeah.
I thought it was
And
just
most
one.
of
It's many black holes all throughout this jump. So yeah, it's not just the black hole, Miss Lisa. Is one of the many black holes. But the one in the center is the massive one. Is the
yeah,
supermassive black hole.
that's the
That's the
super
big
mass.
that's the big dog.
Yeah. See the ones what you're speaking of, Kent, most of those are stellar mass, and those
Hmm.
are the ones that were produced by dying stars.
Right.
So you got them, like you say, they littered all over the galaxy, but they're
Hmm.
not super massive.
Nah,
You know,
right,
that
right.
they're not super massive. They got I think it was the closest black hole to us. Let me look that up real quick. It ain't that far. It's a probably about 1400 light years away.
It'll
And it's
probably be like
called
right here where we at, right? In the Perseus arm, somewhere near there, or
yeah,
what you think?
it's well let's see. Okay, it's called Gaia BH1, which it was discovered by the Gaia Observatory, you know, not the pseudo people. And it's a pseudo group called Gaia or some shit like that, ain't it? Don't get this twisted with that, because they're not part of this. Gaia is, like I said, a space observatory, something like Webb, and it was out there where Webb was in the L2 Lagrange spot. So one thing we do know, pseudos do not do experiments and stuff. So don't get that twisted with, I think his name, what's his name? Billy Carson or something. I think he used
Oh
that one.
yeah.
Don't get this twisted with that. Please don't. You know,
Right, right.
this is a legitimate science here when I speak of Gaia. So it discovered a black hole. It's about 1,560 light years away. So it's dormant, but it's a stellar mass black hole. It's about 10 times the mass of the sun. And it also has a companion with a star about the size of our sun. So, it was discovered in 2022 by the European Space Agency, which they are the ones that operated Gaia.
Hmm.
So, yeah, we got black holes all over. You know, number 3 is approximately 1,926 light years. You know what I'm saying? So,
Right.
and then there's another one, which the first one ever detected was in the constellation of Cygnus, the Swan. That one was, I want to say it was discovered I think it may have been the 70s, could be the 80s. That's one we talked about with Dr. Farrar. And it's discovered by X-rays. There you can't, visible light, you're not gonna be able to see it. You
Gotcha.
know.
Markel had a question about where the Earth was. You went over that earlier, but I believe you said it was in the Perseus arm
Yeah.
area, right? So in the
Can you
outer, yeah, we
can
in the
you expand
suburb.
this picture?
Say it again.
Can you blow that picture up and it'll show you where the sun is on here around
Uh,
that Perseus on, if you can.
oh, I see. I see where it says it. It says the sun is about right here,
Yeah. Yeah.
where that highlight at right
So
there.
that's where we are, Markel. No, we're not at the center. If we were at the center, dude, we probably wouldn't even have
Yeah,
nighttime.
this joint would be this planet to be moving so fast because you
Yeah.
got to think at the center of the galaxy, things are moving much faster because the gravity from that center, that supermass black hole is much stronger near the center.
Yeah.
So you got things revolving around that much faster.
Yeah. And it's more
Yeah,
of them, it's
and
more of
real quick, Kent, there are also rogue black holes that are just they're not necessarily in the galaxy. They're just out in open space that are just floating around. So there are black holes that are just out in space that are just free roaming.
Right, right.
yeah.
Yep.
Yeah.
You
And
gotta do. Okay,
is
go
you got them, and most of those, they come from three body systems. You know what I'm saying? Where you may have three stars, and all three of them may go supernova. So now you got three black holes there, and just by the laws of physics, one of them is going to get slung out. So it's moving across the galaxy and outside of the galaxy. So yeah, you absolutely correct, Kent. I mean, Gary, what you said? What you about to say, Kent?
Yeah, I forgot.
Oh, my bad.
It's all good.
But yeah, Markel. Nah, we're not in the hood, fam. We're in the suburbs.
Yeah, we in the suburb.
We're in the suburbs.
We in the
So,
outskirts.
yeah,
you don't want to be. It get real treacherous in the hood up in there. You don't want to
yeah,
be up in there. You want to be out here. Matter of fact, I think I was listening to a podcast where the dude said that this might be like the Goldilocks zone. You know how our
hmm,
solar system has a Goldilocks zone, where is more prevalent for life. This might be the Goldilocks zone of the galaxy in the suburbs where
yeah.
we at. So
Because
yeah,
you got a lot going on down in the center. Because I mean, of course, you have way more stars. You know what I'm saying,
Mhm.
to contend with.
Yep.
So you add more stars into smaller space. You know what I'm saying? It's gonna
Mhm.
cause for some chaos.
Yeah,
you know?
just like the hood. It's harder to survive.
Exactly.
It's a perfect analogy, yo.
Yeah. So yeah, we out in the suburbs, fam. So we safe right now. Ain't gonna be too many drive-bys by stars. You know what I'm
Nah,
saying?
nah.
Yeah.
Indeed.
But that's like I say, man, I don't want to do too much because this I have to control myself, Kent.
Nah, yeah, you good. You good.
I,
Nah,
I can go on this subject. You know what I'm saying? I can, yeah, yeah, I have to stop me sometimes, just reel me back in. But
nah, you straight.
it's
Well,
amazing how we get all this information. No, I'm sorry. Go ahead, Gary.
no, I did some studying, Anthony. Can I go too far?
Yeah, go, man. Knock it out.
Yeah. So when I was researching this stuff, it was like when I researching it, it was like they were saying that like taking a picture of the entire galaxy would take like billions of years. And since like taking a single picture is impossible, astronomers map it piece by piece using telescopes. And the picture we have today comes from like 3 trillion observations of 2 billion celestial objects over 11 years, like you said. And that's what that Gaia mission is. And that Gaia mission had found like many uh, secrets to the galaxy that we didn't, know about before. And Gaia was built off the uh, Hipparchus mission from 1989, and like their goal was to map 120,000 stars, but like Gaia's mission was to map 1 billion stars. And like Gaia is so accurate that it can like pinpoint stellar positions with like so much accuracy to where it's like measuring like the width of a human hair from like 1,000 kilometers away. Like that's how accurate it is. And so like each star is photographed twice as it spins, and after the light is captured in mirrors, it's directed into Gaia's camera, which has like 1 billion pixels. And the stars are viewed through CCDs, and Gaia detects the star's parallax, which is the tiny shift in position caused by Earth motion, and that allows astronomers to calculate the star's distance with accuracy, and those stars move to photomatic CCDs, which uses prisms to break down the light into different wavelengths. And this determines like the star's brightness, its temperature, its size, and its like chemical composition. And then finally, some stars reach the radio velocity spectrometer, which splits their lights into a spectrum. And this tells how fast the star is moving towards or away from us, like via the Doppler effect. And so Gaia continuously rotates. The telescopes observe stars multiple times at different angles, and that creates like a detailed 3D map of our galaxy. And so like Gaia can scan over 2 million stars per hour. And like the Gaia doesn't just stop capturing like static snapshots of the galaxy. They reveal the Milky Way motion in detail. And like what you were saying earlier, Gaia had proved that the Milky Way doesn't just have two spiral arms, because our galaxy is actually warped. And so one of the main things that Gaia had found out, that like there was a galactic crash with the Sagittarius dwarf star, and that has like changed the shape of our galaxy. And so, you know, that Gaia mission has taught us a bunch of stuff that we didn't know before, and that was the main points that when I was researching this stuff. I know it was kind of long and drawn out, but that was the important points that I found out about the Gaia mission.
Yeah, appreciate that, Gary. Great work, man. That that Gaia, man, it opened our eyes to, a lot that's going on in our own galaxy. So excuse me. But yeah, it's like I said, we're building a model or visual of our galaxy from the inside out. And that mission, they've had like 5 data release points, and they've learned so much. Like you say, that collision with the Sagittarius dwarf galaxy, and there's another one going on now that's actually affecting, the shape of our galaxy. So yeah, it's when you look at it from edge on, it's kind of tilted or warped a little bit due to those collisions. But there's so much space in between stars that you very seldom will you get a star to hit another star. You know what I'm saying? But those collisions do take place. And we do have pictures of galaxies in all different stages of their evolution, because galaxies don't just pop out of nowhere. It takes a lot of gas and stars, but there's a time period, a time frame when all this happens. And there's different types of galaxies. They're categorized different. Like we're a spiral galaxy. We're classified as a spiral galaxy, which is believed to be a mature galaxy. You have your dwarf galaxies. They're much smaller. They're not as defined or massive as the Milky Way. Then you have what's when Andromeda and the Milky Way, collide with each other in so many billions of years, it'll become what's called an elliptical galaxy. That's just a big round, trillions and trillions of stars. But the elliptical galaxies are more spheroidal shaped. You know what I'm saying? I don't want to say round because it's not a perfect circle. but we're getting to that point. But the Milky Way is it's one of the what you would call a major galaxy. It's very big, you know, 100,000 light years across. That's a lot of stars. It's estimated to be a few billions to trillions, you know. So right now we don't know exactly how many stars, but it's a bunch. It's a lot. And but we got, let's see, I'm trying to pull up a few pictures, see if I can get that going. Uh,
I think that's that center that that supermassive black hole we was talking about earlier
oh yeah,
in the
yeah.
thing. Central Sagittarius A.
And you can actually see on this one here some of the other spiral arms. You can see them a little better. The minor arms are what they're called. But yeah, that's what the center of the Milky Way would look like. So if you were close to that, you probably wouldn't have a nighttime. You know, it's just so many stars that will be shining down on us to where we wouldn't be able to tell if it's day or night.
Oh,
You
I
know,
didn't even think about that, man. That's a good point. Like it'll be day all the time, wouldn't it?
pretty much. You know, because there's just
Sheesh.
so many stars, man. You know, I don't know if
It would,
if it would be day, but it'll definitely be like being under the full moon.
but I could imagine the temperature would be a lot warmer too, wouldn't it?
Oh yeah, and
So
you
yeah,
have
that's
probably
why I wouldn't. That's why I was saying like with the Goldilocks zone of the galaxy will be where we're at right now because I'm sure the center is like much hotter
oh yeah, yeah, most definitely.
from the
And you would
concentration of
have
stars. You know what I'm
a lot more radiation too.
saying? Man, yeah,
You'd be dealing with a lot more
most,
radiation.
most definitely.
So it's that's just one of those things that, like I said, we don't nothing we learn outside in the cosmos is going to hinder our life here on Earth. But it's just getting the understanding and knowing what's going on out there. It's just, amazing to me. You know what I'm saying? That's what amazes me about, the cosmos. It's just so much going on out there, man. And it's a slow subject, because it takes a lot of time. No, ma'am. No, we're not. If anything, it will be an asteroid or a comet or something like that. But as
Yeah,
far as like another star or a black hole or something, no, we're good.
yeah, because you got to think.
Good.
You got to think, Miss Lisa, that these stars are so far apart. Like
Mhm,
space is huge. It ain't just like it ain't like the movies where they riding through space in they spaceships and they pass this asteroid 1 second and then 2 seconds later they pass another asteroid and then these stars is over. Like nah, it's so far apart that
mhm,
even when it merges, the stars are still going to be far apart. The gravity is just going to be strong enough to affect the way they merge together, but you still probably won't have like collisions like that.
mhm.
You know what I
Yeah,
mean? Because it's just
that,
so much space. It's so much. You know what I mean? It's unthinkable.
yeah. That's one thing that I don't think we have um, witnessed yet is a star collision due to galactic merger.
Right.
You know what I'm saying? I don't I don't think that we have I've never seen any pictures or articles or anything on it. Everything I see says just too much space in between.
Too much.
You know, they will coalesce, but nothing will get to a point. to where they would hit each other. Now you do have star systems, because like our sun, man, our sun is basically like an anomaly. You know, for the most part, when we study stars, they have companions. You know what I'm saying? Like Sirius A, one of the most, popular stars out there. Well, it has a companion, Sirius B. Now, Sirius B has become a white dwarf, but at one time it was two stars. You know, if you look at the North Star, I think the North Star is a 3-star system. So it's 3 stars that hey, what's happening? That my kinfolk there. What's happening, Jack? Appreciate you coming through, fam.
Sure indeed.
But when you look at the North Star, if you look at it through a telescope, you can resolve the 3 stars. There's 3 stars there. Betelgeuse, one of the stars that's expected to go supernova pretty soon. They found a companion star with it. You know what I'm saying? So most stars we see in the night sky are not just a single star. They have a companion or a few. But our star, the sun, we don't have a companion star. It's just one star. You know what I'm saying? So that's kind of it's I don't want to say rare, because it's not rare, but most stars that we study, they have, multiple stars. Even the smallest, a red dwarf like Alpha Centauri, it has a companion, Proxima Centauri, and those are red dwarfs. Those are those are the smallest but most abundant stars in the galaxy, the red dwarfs. We have more of those than any types of stars. We talked about the O stars, the A, the big, huge ones, and then the average stars like the sun, which is a G star. Well, the red dwarfs are the M types. They are the coolest and the smallest, but they're more abundant. But they have planets. And also, like I say, they have companions. So our sun is a little different, and maybe that's what it takes for intelligent life to evolve. Because if we had 2 stars, it'll probably be a whole lot different, man. You know what I'm saying? Well, I know it'll be a lot different, but how different, I don't know. But things would be different depending on the size of that second star and, the composition of it. But being out in the suburbs and then just having 1 star could be the reason why we are here. You know what I'm saying? Don't get what I'm saying twisted. I'm not saying that's why we're here. No, but that could be the reason why we have life. And that could also be the reason why our solar system is, functioning the way it is, because it's only 1 star. But when you really get into it and you get to studying these stars, you'll see they are in systems. There's multiple stars. And it's believed that over 60 supernova, over 60, like, I think they say like 60 supernova going off is what led to our solar system being formulated based off the composition of what we find in our solar system. So it's, science is great, man. What I'm saying?
And I don't think our threat is what someone asked about, like a collision. I think kind of what you said, our threat is either an asteroid or like what you were saying about supernovas. And like it could be millions of light years away, but if a supernova was directed our way when it went supernova and one of them gamma ray burst is pointed at us, we're done.
Oh, yeah.
Like the gamma ray burst is the second most powerful thing in the universe after the Big Bang. So if there is a star that were to go supernova and one of them jets were pointed at us, that's it.
Yeah, that's like staring down the barrel of a gun. You know, you have all of that energy concentrated into a small beam. And it's been said that has happened. That caused one of the extinctions. It killed the atmosphere. I think it was, I can't remember which one it was. And that's not, you know, concrete in stone. It's just a theory or a hypothesis. Put it like that. It's more or less of a hypothesis. But they said one of those great extinctions that we experienced here on Earth could have been started by a supernova going off in those. We were right on the edge of catching the powerful beam, and it destroyed the atmosphere. So there's the jury's still out on that. You know what I'm saying? But
Yeah, but it's just like you were saying about the sun. There's no warning. All of a sudden, you just look up in the sky and you're done. Like because that light's been traveling for possibly millions of years towards us, and so it's just gonna hit us at like there's no warning.
Yeah, it's moving too fast, and no, you don't have a warning. And that's the issue with a lot of asteroids, especially when they're coming around the sun, because the sun is so bright, it's hard to track them. But I think it's the Vera Rubin Observatory that they just started operating in Chile. I think that's where it's at, in Chile, up in the mountains. They're able to track a lot of asteroids and stuff now. So maybe we'll be getting better with that. Miss Lisa, no, the asteroids are basically pretty much leftover material from the formation of our solar system. So the asteroids are just, you know, material that didn't form into a planet. And the same thing with comets, but the comets are much farther away. The asteroids are pretty much located between Mars and Jupiter in the asteroid belt, which some say that should have been a planet. But due to Jupiter's gravity and Mars's gravity, the planet basically couldn't form. But you do have a couple of dwarf planets floating around in there. You can see where a planet was trying to form, but it just, I guess the gravitational forces were too great, you know, for it to form. So it's just a band of asteroids around the inner solar system. So it kind of separates the rocky planets from the gas giants. And that's where most of those come from. And then we have, you know, further out beyond Neptune's orbit, you have the Kuiper Belt, which is basically the same thing, but it's much, much colder out there, you know, in the Kuiper Belt, because you're much, much, much farther away from the sun. So those would more than likely come in as comets. And then beyond the Kuiper Belt, you have what's called the Oort cloud. That's all comets. You know, they're rocks like asteroids, but they're much farther away. They're much colder. So when they come in close to the sun, all the gases and stuff start to stream off of them, and you see a tail. And, you know, but you don't really see that with an asteroid. You don't see a tail for the most part with asteroids because they're closer to the sun. They're not gaseous or as gaseous as something that would be further away. So that's pretty much the difference. It's not necessarily pieces, you know, kicked off of something. They're just leftover material from the formation of our planets.
Yeah, but kind of to what Miss Felisa was saying, the ones that are separated between Mars and Jupiter, those asteroids are constantly bumping and colliding into each other, and so there's a much more chance of an asteroid coming towards us because it got knocked out of, you know, two collided, and it kicked it out of its normal orbit, and so that it's more likely that an asteroid would come towards Earth from that than say like what he was talking about, the Oort cloud, or the one that are, you know, way out in the outer edge of our galaxy, or you
Yeah,
know.
yeah, that is correct. Yeah, you got the biggest threat would be the asteroids. Because like you say, Gary, when they hit each other and one gets ricocheted out, then you never know what its trajectory may be then and how much time you have. You know, so that's the immediate threat. Comets, we can see those we can pretty much see comets coming, you know, because the closer they get to the sun, they start to grow a tail or a plume. So we can pretty much see those coming. But the asteroids, yeah, they're dangerous, Miss Lisa. They are dangerous. And no, it's not the arms that prevent us from going into the black hole. It's more or less the arms are just, you know, created from the motion or the spin of the galaxy. Because the galaxy is spinning, we are spinning, we are orbiting around the center. I think they say it takes like 250,000 years for the Earth to make one, I mean, for the sun or our solar system to make one complete revolution around the through the galaxy. And those arms are basically like denser areas. Like like it's kind of like being in traffic. You know how when you're in traffic, you come to a tight area, it slows down, or maybe even come to a stop, and then you don't see an accident or nothing, but then it just picks up again. Some astronomers, you know, kind of correlate those arms to being areas of a little more density. So you have more material kind of bunching up, and then it kind of opens up. So that's kind of how they, you know, try to correlate it to get an understanding. It's like being in traffic, and that's what the arms are. The arms are the heavy traffic areas, and that's where you find most of your, like I said, most of your gas and things like that. Like all the major star forming regions would be located in the arms because that's where the most of the material is. It's in those arms. And you know, y'all can take this picture and kind of, you know, blow it up and look at it, and you'll see those areas with the clumps of gas. And those, they're very big and they're huge. You can see them like in my pictures of Andromeda and other galaxies, you can actually see those areas. But that's where you have all the star, you know, the majority of the star formation going on. And it's those stars that light up those areas to make them visible across the universe. But, you know, with a telescope, of course. But yeah, let's see. Here's a thought I've had for a while. What's the chance of all the space junk falling to Earth? We have a great chance of that. And if I'm not mistaken, it happens already. You know what I'm saying? There's things that are falling to Earth, you know, satellite pieces of satellites and all kind of stuff that actually falls to Earth. But being that the Earth is surface is 70% covered by 70% covered by water, most of that stuff falls in the ocean. Now you do have some pieces that, if I'm not mistaken, we had some stuff fall in East Texas some years back. Wasn't, you know, too close. I mean, too far from Shreveport, where I'm from. They had some space debris just fall out of, you know, fall out of the sky. But that's a tricky situation there, man, with all the stuff that we're putting out into space from Earth. You got a lot of what they call space junk out there. It's a lot. So yeah, that the probability is high, but a lot of it we don't see or deal with because it falls in the ocean. You know what I'm saying? A lot of that stuff falls in the ocean, and that's simply because we're 70% of the earth is covered by water. So that's just one of those things we have to kind of be careful, but hey, when you're a big industrialized country, you know what I'm saying? I guess that's just part of the game. But things like Hubble, I don't think we'll have that problem with Hubble. It's James Webb, things like that. I know we won't have that problem. But like all these other little GPS satellites and what Elon got going on with Starlink and all that, yeah, that could become a problem. Most definitely. But yeah, man, if it's any other questions, because like I said, I don't want to go too far into this. Just want to, hone in on where we are, and then we'll start throwing, like when we come back next week, I'll have the picture set up and with this diagram here, and we'll point out where those pictures line up on this, based off of this map here. We'll line those pictures up with which arm it's in. We got the minor arms, we got the major arms. We went into the bar, the galactic bar going across the center. So that's enough to chew on for a week. We'll come back next week and we'll plug in. Now, we did talk about where Bobby's Nebula would be located. Like I say, that's in the Orion Spur. It's not too far from us, like 1,400 light years. And when I say not too far, I'm speaking on galactic distances. You know what I'm saying? 1,400 light years, that ain't nothing to that ain't nothing to joke, to sneeze at. That's a distance that we won't be able to cover. We won't. We as humans in our lifetime right now, we'll never get there. We'll never get there. But like I say, it's pretty cool to be able to at least visualize it and talk about it. Let's see what we got. Yeah, they got a parade of planets going on right now. Well, I think Saturn has already set, so it might be too late to see Saturn. But I know Jupiter and you got Jupiter, Mars. Let me pull up my stellarium. We got Jupiter and Mars up right now. So let's see. Jupiter is pretty much basically about overhead. Uranus is getting ready to set. So you probably won't be able to see Uranus. Oh no, Mars will be coming up before sunrise. So you have to stay up pretty late to see Mars or get up early, whichever way you want to look at it. But Venus and Saturn, they were pretty close to each other. They've already set. If you look to the west, Uranus is not too far from the Pleiades, or what we refer to as Dr. Mayat. Uranus is a little bit south of that or up under it, but you won't be able to see it with the naked eye. It's too far away. It's too dim. So you got two of them out right now. The first two, like I say, Venus and Saturn, they set right after sunset. They're already below the horizon. So, but no, we didn't. I don't have as far as getting the planets, I can get them with my big one, but I don't have the capability to take pictures on that telescope. But that's the best one I have to look at planets. And with that telescope, the big one that I had out last week, that's a 12-inch Dobsonian. Now looking through the eyepiece, oh man, those planets are beautiful, and I can see them all: Neptune, Uranus, um, Venus. I can see all the planets with that telescope, but I just don't have the capability to take pictures, on it. So that's one we'll have to do visually. But I'll get me a rig that'll be good for planetary pictures as well. Eventually,
Hey
it's
Anthony, I just went outside when you said that, and went outside and looked just now at the moon, I saw like this big ass halo around the moon. What is? I think I remember. Is that like ice particles or something? Like,
well,
do you know
no,
what I'm
that
talking about? Like, I only see it rarely, but when I just went out because you were talking about Jupiter and uh, Uranus, I went and looked at the moon, and there's this big circle around the moon right now. And what causes that? Is that like ice crystals
no,
in
that's
the
that's
atmosphere?
that's basically gonna be the atmosphere where you are, Gary. It's probably of some light clouds. That's all it. Because when I look at it, I don't see that. From where I am. You know what I'm saying? So that's basically some thin cloud cover in your area. You know what I'm saying? So that basically will be tied to where your location. Yeah, that's a good app to have kinfolk. Yeah, that's Stellarium, man. And if you see something odd in the sky with Stellarium, you just point your phone at it. After you get it calibrated, you point your phone at it, and it'll let you know exactly what it is. You know what I'm saying? So that's one reason why I like it. But I believe we talked about this before, me and Miss Juju, and if I'm not mistaken, she did mention that most of those apps are like that. So you can't go wrong with either one. It's just that Stellarium is my go-to. I really like Stellarium.
Yo, we got the God killer in the building. What it do?
What's going on? Space Age Anthony. What's going on with you guys?
Peace, fam. Appreciate you coming through. Just chilling, getting it in a little bit.
Peace
Yeah,
on.
man.
Peace,
Man,
peace.
sitting back saying, yo, I don't want to show you
Hmm.
lot on my head, man. I'm gonna let y'all rock, man. That's a good combo. I just asked you to then Kim put the dummy link in there. Fake link. The fake
He
link.
ain't fake you out, did
Yeah, it sent me to a old thing. He tripping.
he?
Trying to fake me out.
Yeah.
I think he did. I think he did it on purpose, yo. Yep.
But
Yep.
yeah, we
Great
appreciate you
conversation, though.
joining in, though, fam.
Yeah,
As
it's
always.
all good. I'm listening if I got something to add to, you know what I mean? Although we got a lot of space cadets around us, but yeah, it's all good.
Yeah, we're gonna keep the people. You know what I'm saying? We're gonna keep them educated, dog, so they don't fall in them rabbit holes. Get drugged down to their level and beat up with experience. You feel me?
Yeah, for real, right? Good be draggy right there. How you say that again? Say it again.
When you're scientifically literate, they can't drag you down to their level and beat you up with experience.
Mm-hmm. Yeah, it's real
Because
tough, man.
I was listening to your show the other night. A dude, it was some cat on there. I think his name was Omar. Not Omar Reed, but it was another dude. I think that
Mm-hmm.
was his name. But anyway, I got to thinking when you was trying to explain to him about how
Terrible.
there's other ways to understand evolution without the bones. And
Right.
I got to thinking, well, maybe we doing this wrong. You've been published. Maybe you need to teach these clowns how to present a paper to overturn the science instead of arguing with us.
Right. Yeah,
You know
go
what
on
I'm
with
saying?
them.
Because we're communicators, dog. we we're just trying to enlighten the people on the scientific processes and how that goes, but
Mm-hmm.
they trying to overturn the field. So we might not be the right ones to talk to for that. So just write you a paper and present it and see how far you get then. See what happens. You get laughed out the building with all that foolishness.
Completely out of the building, man. I I don't know, man. I thought, just like, when you, man, there's just different lines of evidence, and over time, as the field learns from what they learn from, they'll have more evidence to add to the field, right? And so it's not one thing that they getting their answers off of anyway. It's a collection of things. So you may not have this. You actually went to fucking Mars, right? But you could pretty much tell what it was composed of, right? You don't need to actually go there because there's other lines of evidence. And how about this? You send a tool there,
Mm-hmm.
right, and send you back the chemical elements, the chemical breakdown, right? You don't need the actual dirt. Chemical
Mm-hmm.
components in it. He wants you to have the actual dirt, the
Yeah.
actual bone. Like it's just ridiculous. And I think it's just that thing, and that's why we have such a hard time. You get it? Because of
Yeah.
religious thinking, you know, everything out of nowhere. So yeah, man, we're tasked with it, bro. It's hard. Yeah, that religious thinking have you think a cosmic force with a hand reached out the sky and grabbed that dirt and blew the cosmic wind and formed man, and then that rib put him to sleep, put him to sleep, perform some type of surgery, yeah, and bam, a woman comes, fully functional, bro.
Yeah.
Bro, so yeah, that's what we up against, though, bro. We'll just keep rocking, but we up against the pop up out of nowhere scenario, bro. That's the spook. No steps.
Yeah, it's levels to it, man, and it takes time, and it's way more time than we have on this earth. But we have enough time to figure it out, dog, if we just stay genuine with
Yeah.
it. You know what I'm saying? We got enough time to figure it out. But I'm not here to trick anybody. I want y'all to understand what I do, and that's why I present it the way I do, because that's the way I understand it. And if that can help one person, I mean, I'm good. Of course, you want to help the masses, but boy, we got a tough fight on our hands. it's a journey though. It's a journey, well worth it. Because
Yeah.
I've learned a lot, just by dealing with this community on how to approach my studies and my passion. So yeah. But I mean, that's pretty much all I got for tonight. Ken, if y'all got anything else or anybody want to jump up on, I'm more than happy to answer any questions. Any kind of interaction is welcome.
The war against religious thinking, Religious doesn't tell you what to think, right? It shows you
Mhm.
how to think,
Yep.
okay? And as you think in that manner, through scientific literacy, you start to see the world. Simple as that. You get to see what it is. I mean, it's just very interesting in religious thinking there. So and the thing, how does a person be religious and then working? How to shift those gears, man. You gotta lock in. You know what I'm saying?
Yeah.
Yeah, boy, you believing and praying, and then go in that lab, boy. Got to say your final prayer outside the results. And you know what? Even trying to explain people that is extraordinarily hard. You know what I'm saying? Like the date is you implement your spookism into the data. You can't say, well, I believe that this number was brought to me by the creator. And you write that number down and you plug it in. Yeah, it's crazy, bro. Yeah, very interesting though. Yep, that's it. I just wanted to get that in. Big up to all the keep supporting the shows, man.
Well, just to piggyback off what you're saying, that line of thinking that made the scientific method so important. You have to be able to separate the two. You know what I'm saying? So just having that, anything that's gonna make you question yourself is a good thing, which is what a lot of people don't do. So you have to be able to at least question yourself or your own thoughts.
hmm 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 So you remember we was weeks ago we was doing I was doing the show and we was talking about the history of the scientific method. Taking
Mm-hmm.
it now. It was interesting how they end up breaking away from the Greek tradition. I think it was Platonian or Aristotelian, whatever. They broke away from that line of thought, right? And once they broke away from it, because once you know not to go back. You get that, right? It was crazy, but they
Yeah.
but they broke away from those old, and they was able to to put things in motion to have that modern science. Man, I think I'm gonna. It was very interesting how that how that all played out like that. But once they broke away from it, there's no doubt there was and so like for most of us, once you start really having you know through the lenses of scientific literacy, there's actually no going back. You actually see things for what is and and a lot of times you're at odds with people. They'll start to make it's like this. You got a group of nuts. This is no lie. They swear they see the world differently. They see all that, and don't understand why you can't. You can't see what they're doing. You can't see Bill Gates them trying to kill you. You can't see this with the people. And then you got scientifically literate people who can actually see the world for what it is,
Yeah.
right? So with all that. So it's hey man, it's a man. All I can tell people is you're not ready. The box, the Pandora's box, don't keep it closed. Don't open it up because once you go on that road, you're gonna be very skeptical about a lot of things people say to you. Yeah.
Yeah, man. You got to keep asking questions. It's just that's just what it is. And that fits right into my realm, because I like to ask questions. Now, if I don't know, I'm gonna ask a question. The only dumb question is the one you don't ask. Because if you don't know, man, you just don't know. So, you know, ignorance is not a bad thing. Being willfully ignorant is though.
Is that what it is? You on
Yeah.
purpose. You willfully ignorant on purpose.
Yeah. If you just, if you just not gonna even listen, that's a problem.
Oh,
You ain't
yeah,
learning nothing.
yeah. He had me frustrated, but he accomplished his mission. Yeah, and once I realized he just frustrated me, and I was like, Shuddy, don't let him get you. He just fucking, yeah, he wild out. Then he gonna say, well, okay, I see what you saying. We done fought for half an hour on that.
Yeah.
You can't, why you keep, why is that so? The things they'll fight against us with will be things that is important to them, not even to science. It
Yeah.
is important to the religious mind. See, the religious mind, you gotta have those bones.
Hmm.
But like you said eloquently, you say, well then how can you same scrutiny on your own thing? Because it's definitely there for you. You got endless possibilities on what don't make sense, and you don't put the same amount of scrutiny on that you're putting on us. That doesn't make. I like the way you said that though. You get it like the religious people who scrutinize science to death have those same exact questions, but tenfold on their own thing.
Yeah.
Like, why is the Earth only 6? Why only talking about 6,000 years?
Yeah.
How can you verify that person is actually a spy bot? Right? Couldn't you just be saying it? How come they don't know about the whole world?
Mm-hmm.
Because they act, they mentioned every place they went. How come they don't mention the other continents? They don't ask them questions, bro. This God
Mm-mm.
didn't have the ability to tell all the millions of people that predate that for the last however long they think humans been on Earth. But how come other groups of individuals, Persian, how come they all have different gods? Why didn't God just tap them on the shoulder and say, "I'm your God"? Why is it that I'm the God of Israel? Why did He pick them out, right, and not pick out everybody? Says everybody. Why He picked them in particular? These are questions they could ask themselves,
Mm-hmm.
right?
Yep.
How 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 do you take a rib out of a woman? I mean, out of a man. Why these people? Why Jamaicans with belly buttons?
Yeah.
Right? This is that, bro. And not to belong the point, but as I was listening to, I can't even say her now. I always mess her name up. Gift stick. What's the name, Kent? Snap out of it, Kent. Where you at, Kent? Gibbon, I believe. Am I saying that right? Gut stick Gibbon. And she was doing a presentation, and she talked about how the geologists could not earth geology because they all base it off the flood. So everybody studying the earth at that time all marked time based off of the Great Flood. And I forget the guy's name. I'm gonna go back and look at the presentation. It was one of the traditions, and he is said to be he actually starts the field of geology, right? Break away from the flood because Earth did not make sense based off of they dating of the flood, yo. From religious traditions, the world around you will not make sense. The
Mm-mm.
natural world around you will not make sense. Stay in those traditions of religious thinking. It won't.
Yeah. Hey, that's a fact though. Real talk.
Mhm. Yeah, I think I'll end it on that. We'll clip that. we clip them up right there. That's an interesting piece right there. But go ahead, man. I ain't going. I know how long y'all been on
Yeah, my
Uh,
bad, man. Got a phone call.
here.
Shit, it been about an hour 24. I mean, if y'all want to go ahead and
I'm good. I'm
yeah, I put
good.
the link out there. Ain't nobody wanting to jump on right now or whatever. So hey, if y'all got any questions or whatever, and y'all ain't get to get on, just put it in the comments, and we'll get at you
yeah, most
on the
definitely.
next show.
And I just dropped the link to a past show that it was me and you on. We did on Stars. Y'all can go check that out, man. It's a lot of information in there. Basically, that kind of ties into what we talked about last week and this week today. So it's mainly it's a presentation on stars, but it's a good one. It's a lot. It ain't that long, about an hour long, a few slides, but it's very thorough. It's a lot of information on there. So, and if you've already watched it, hey, watch it again. You know what I'm saying? It's a pretty good one. But yeah, I do appreciate everybody showing up, coming through, comments, questions. Hey, much love. I always say, when you're scientifically literate, they cannot drag you down to their level and beat you up with experience. See? Keith.
Pseudo killer, intellectual sunsling, ayy. I'm a pseudo killer, intellectual sunsling, ayy. I'm a pseudo killer, intellectual sunsling, ayy. Pseudo gon' die, they saw us. Pseudo killer, I'm a pseudo killer, intellectual sunsling, ayy. I'm a pseudo killer, intellectual sunsling, ayy. I'm a pseudo killer, intellectual sunsling. Who do you believe in? People bringing misinformation when that information ain't disinformation. That's disinformation. Gotta know the difference in information. Get information with the pseudo killer army hunting pseudo. Cause you gotta train your mind to fight against them pseudo judo. People with the scholarship salute, we give them kudos. But the people with that look of shit, we look and see straight through those like telescope. If you ain't speaking fast, we gotta tell them folks and let them know the truth. You bringing malinformation to blast, then you the Ku Klux. Like say, don't talk me to death, bro. What the proof of? Good juju chillin', why you wanna go way bad juju up? Shalom boy got the tank in the cut. I'm in Sosa world plotting on the kick though with Kent. Come and Tiffany gave me the pseudo names on the list and said went and got the low. Anthony got him in the scope, Gullah and Gozy. Make sure DNA ain't a problem for them folks, cause a pseudo gon' die, they saw us. I'm a pseudo killer,